In this video, we're going to use the sum and difference formulas to find exact values of trigonometric functions, and specifically, we're going to focus on part D of this particular problem by finding the tangent of theta plus pi over 4. So first of all, there is a trig identity that we will use, the tangent of a plus b or alpha plus beta, and you can see I've already pasted that here, just took a screenshot of that here. And for this particular problem, we know one of the values of those angles. So that second angle is pi over 4. So I've gone ahead and substituted these values here. I could take this a step further because based on the unit circle, we know that tangent of pi over 4 is 1. So we could at least make that substitution here and here, but we're left still not knowing yet what tangent of theta is. But if we return back to our original problem, we are given some information that we could use to find it, and that is that the sine of theta is 8 over 9, and that theta is in quadrant 2. So tangent of any angle is defined as sine over cosine of that angle. So again, we have sine of theta, but let's find cosine of theta, and that's where a trigonometric identity will also come into play. And in particular, that's the Pythagorean identity, and that's this one, sine squared theta plus cosine squared theta equals 1. So let's use that, and what we know that sine of theta is 8/9. We're going to have to square that. And then we could use this equation to find cosine of theta. So let's work through that process. Subtract 64 over 81. And then take the square root of both sides. And just for a moment, I'm considering both the positive and negative answer to that operation of taking the square root of both sides. But when I further investigate, I see that theta is in quadrant 2, and in quadrant 2, cosine is negative. So I'll only keep the negative solution. So now, moving back to tangent of theta, that's what we were trying to go for by taking that side step. We know that sine of theta is 8/9. We know that cosine of theta, we just found that. And so let's simplify this. Now I do see a radical in the denominator. I could go ahead and address that by rationalizing the denominator. Oops. Fix that. Okay, so at least now it has a rationalized denominator, and this is tangent of theta. Remember, the reason we were going for that value is because that was the only missing value from our sum formula up here. So just to have some more space, I'm move that over here to this side of the screen. Again, we already know tangent of pi over 4 is 1. We just found tangent of theta. So let's make these substitutions into our identity formula. I see a complex fraction we can't leave it like this, okay, and plus, of course, I could go ahead and do that, I suppose. So let's multiply both numerator and denominator by the common denominator, 17. So I'm just distributing that 17 to both terms in the numerator. I'm going to distribute that 17 to both terms in the denominator. And then I still have here a radical in the denominator. So again, we don't want to do that or leave it like that. So let's multiply by 17 minus 8 square root of 17, because that will allow us to rationalize the denominator. But to keep the balance, we need to do the same to the numerator. So let's multiply all of this out. All right, so that's just distributing here and here. So now let's do the same with the second term. Okay, and again, that was distributing here and here. All right, so I do the same thing with the denominator. And again, the reason why we always use the opposite sign here, or conjugate, you could say, is because we want these terms eliminated, and they contain the radicals, so that when we further simplify, all right, here's where we end up with that step. All right, I was a little suspicious of all these large numbers here, so I just went through to find, do they have a common factor? And they do. It's 17. So I could divide each of these by 17. But it's uncommon to leave negative over negative like this, at least at the, I guess, in front of the fraction, or to be dividing by a negative, I guess you could say. So I could further multiply both numerator and denominator by -1. And end up with this final answer. Notice that actually the answer that was provided over here is the same as this first answer. They've just swapped the terms in the numerator, putting the 81 first. And that negative for the 47 would be placed out in front of the fraction. So either of these should work out.